So I hope you're doing good. And let's have our next speaker. So our next speaker is Adam Klein. And Adam is a software architect that loves front end technologies and is really obsessed about the beauty of React hooks. And yes, he's going to be talking about React hooks. And he's a co founder of 500 Tech, a web consultancy based in Israel. Hi, Adam. How are you?
Hi,
How are
how are
you
you?
doing?
I'm good. I'm doing good. How are you?
I'm doing good too. How are you feeling? Are you excited for the talk?
Very excited.
Thank you. Thank you. So, as you already know, all of us in the audience are already excited about your talk. So, over to you, Adam.
Thank you. So, as you can see, I'm really excited. I pulled out all of my hair. I'm broadcasting from Tel Aviv, Israel. Really excited to give this talk. It's a deep dive into React hooks. So I assume you know about React hooks. You know the basics. You know what they are. And I'm going to talk about the use state and use reducer hooks. Let me share my screen. I hope you can see it. So this is a deep dive talk, which means that I'm going to talk about how things work under the hood, which means that you don't really need to know anything that I'm talking about during this talk. You can work with React hooks for years, even be an expert about React hooks, and not know what I'm saying now. But the reason I think this talk is very important is because it helps you gain more confidence when you work with hooks, when you know how they work under the hood. If you get weird behavior or some performance problems, then it helps you debug all of these weird problems. So the reason I created this talk was because I heard a lot of times in different forums, people ask, how do I call the second parameter to set state like I had on classes? How do I use that with hooks? I want to do something after the state is updated. So what I came to realize that if people knew exactly how hooks work under the hood, they would already know the answer to this question. They wouldn't ask this question. So let's take a simple code that uses hooks. We have a use state with 0, which is a counter. We have a button with an on-click event handler. And the event handler calls setCounter, and it passes in an updater function. If you didn't know, you can pass in not just a value, but an updater function. And this function takes the previous state and returns the new state. So let's dive into what happens when you call setCounter and pass in the function. So what I used to think that happens is that you call setCounter, React manages the state of the hook for us. So in case you didn't know, all of the hooks are in a linked list because they depend on the order of invocation. And we don't manage the internal state of the hook, React manages it for us. So when we call setCounter, I figured React takes the current value of the hook, which is 0, gives it to our updater function. The updater function returns 1, and React updates the state to 1. Then it triggers a re-render to the component, and when the component re-renders, we get to the use state expression again, and it takes the current value of the hook, which is 1. It turns out this is wrong. And this is what I used to think before I started reading the source code of hooks. So let's add some console logs and show you in real life that this is the case. This is not the case. So I have pretty much the same code here. just arranged differently. So we have an event handler on click we call setCounter with an updater function, and we console log render. So let's see what happens when we click the plus button. So when we click the plus button, the first thing that happens is the component re-renders, and only then we get the update, which is very strange. We expected to update the state first and then re-render. Now, what's even more strange about it is that the first time we update, it does happen in the order we expected. So first it calls update, and then it calls render. So this is very strange. What's going on here? So let's talk about first how React updates the state. So what React really does, and this is a simplified version, we call, every hook has another queue, which is the update queue. So every time you want to make an update to the state of the hook, it doesn't get performed immediately, it goes inside the queue. And the queue is performed lazily, which means only when React really needs the new state, which is during render. So only when you call use state again during the next render, React will perform the update queue. So let's walk you through the process. You call setCounter. React takes the updated function or the new value, puts it inside the queue, and then schedules a re-render, basically turning on some flag that says this component needs to re-render. There might be more updates, either to the same hook, maybe to other hooks inside this component. Maybe we call a function from our parent component that updates some state, and we can also dispatch some action to Redux, which causes more states to be updated. So there are a lot of components that are scheduled to be re-rendered. And then sometime, and we'll talk about when later, React will decide to re-render the components. So React re-renders our component, and only then when it calls useState again, it checks the queue, sees that there are pending updates, and performs them lazily. So it will take the first update, then it will call our updater function, get back the new value, and update the state of the hook, and consume the entire queue and move on. So let's add another console log and see for ourselves that this is indeed what happens. So we still won't be able to explain the first call, but at least the next calls. So I added another console log after use state. Let's click on the plus. And now we can see the first thing that happened is render, because when we called setCounter, React still didn't perform this update. It just put it in the queue and re-rendered. So the first thing we have is the render. Then we get to use state, and then React looks at the queue and says, okay, I have pending updates. Let's perform them. That's why the next update console log we get is the update, because it actually runs the update. And it updates, it gets back 1, so we get back the new value, which is 1. And then we get the after use state. So now we know why this happens. So to summarize the first part, every update to a hook is queued. And after all updates are done, the component re-renders, and all of the updates are performed lazily during the hook invocation. So now we can already answer this question. What about the callback to this.setState? How can we run code after the state is updated? So we can ask ourselves, okay, when is the state really updated? Only during render, before that, it's not even updated yet to the new value. So how can we do something after the state is updated? We have to do something after render, which is using an effect or a layout effect. So if you want to respond to a state update using hooks, you just use a use effect and put that state inside the depth array. Okay, part 2. What about render bailout? So let's take this code for example. It's very similar, except we update the state to the same value that it had before. It was 0, and now it's 0 again. So we said that React first re-renders the component and then runs the update. But we would expect React to say, okay, let's try to update, see that the new value is the same, and bail out of render or avoid re-rendering. But we know that it renders first and then updates, so how can it bail out of render? So remember this slide? There's actually another step that I didn't show before, which is that React sometimes eagerly calculates the new state in order to see if it needs to bail out of render. So it calculates the new state immediately and checks if the new value is the same as the old value, then it doesn't need to re-render the component and it bails out of rendering. But if the states are different, then it schedules a re-render. So why it happens sometimes? First of all, if this component is already scheduled to re-render, then there's no point in doing this eager computation, and React will just do it lazily. Also, if React determines that this update changed the value in previous invocations, then it probably will change in this invocation as well, so it doesn't do the eager computation. So React did the eager computation, decided to re-render, but it also saved or cached the result of the eager computation, so it doesn't have to do it lazily again. Then we continue the cycle, we re-render the component, we get to use state, and React sees I have an update, an action in the update queue, but I already calculated the result, so I don't need to run it again. I will just take whatever was cached and update the state of the hook. So now we can finally explain why the first time we updated the state, we had the update run first. So here, if I click for the first time on the plus button, now we know what happens. We call setCounter with the update function, and React says, okay, this is the first time it was called. Let's see what the new value is. So it calls the update function immediately or eagerly, passes in 0 and gets back 1. And then it compares and says, okay, 1 is different than 0. We need to re-render. It schedules a re-render. That's why the first console log we get is update 0. And then React re-renders a component. The next console log is render. And when we get to use state, React looks at the update queue and says, I have a pending update, but the result I already calculated. That's why we don't get another call to update. And the next thing is after use state, which is what we get here. Now, the second time we hit the plus button, React has an optimization. They say, okay, the last time I called this update function, it returned a new value. So probably I will get a new value again. So there's no point in doing eager computations. Now, it's not part of the spec of React. It's not in the documentation. It's just part of the optimizations in the source code. So it might as well be that 1 year from now, this behavior will be completely different. It's just at the discretion of React team how they want to optimize this. So we know that React is trying to optimize, but what about the times when React does lazy computation, but still we get the new value is the same as the old value. Does it mean that React continues to render and it can't bail out of render? So we can find the answer actually in React documentation. They say that React may still need to render that specific component again before bailing out. That shouldn't be a concern because React won't unnecessarily go deeper into the tree. So what this means is basically React will call our render function. If it sees that nothing changed, it won't update the DOM and it won't render the child components. It will just do a shallow render, which should be fine. Our render function shouldn't have heavy computations. And what they recommended is if you do have heavy computations, you should probably use a memo or make them less heavy, I guess. So to summarize, React sometimes computes eagerly to bail out of render. It caches the eager computation to avoid recompute. And anyway, if computation is done lazy and state didn't update, it bails out after shallow render. Cool. So part 3, when does React re-render? So remember this slide? We said that sometime after the updates, React will say, okay, now it's time to re-render. So how does it know that we finished updating? How does it know, okay, now's the time to render? Does it have some kind of timer? So the answer is very simple. Every event handler that we run, for example, on click, on mouse enter, on scroll, etc., runs inside what is called a batch. So here we have on click, it runs inside the batch. And the batch means that everything that happens inside the batch is queued. So if we call set counter twice, for example, we increment it twice, the first update is queued, the second update is queued again as well. And when the on-click event handler finishes, React re-renders everything that was scheduled to be re-rendered. It's that simple. But what about asynchronous code? A lot of our code is asynchronous. So what happens here with asynchronous code is that we're waiting for something to come back, which means that the on-click event handler is already done before we got to the actual set state, which means that the batch is done. And in this case, every call to set counter will trigger a render. So here we will get 2 renders of the component, and in the previous example, the synchronous one, we got only 1 render. So usually this doesn't cause any problems, but sometimes it can cause flickering of the UI or performance problems if your rendering is slow. So I recommend first to solve your performance problems if they are slow. Sometimes you will still get a flicker or a jitter. So there are 2 ways to solve this. Either combine your state to one state object, and then you can update the entire state in one atomic transaction. But then you miss out on a few advantages of hooks, like separating of concerns and reusing code. So what you can do is call React DOM unstable batch updates, which basically does the exact same thing. It runs your code inside the batch, which means that in this case, we will only get 1 render. Now, you probably noticed the title of the slide, Don't Do This, and you probably also figure out by yourself that calling a function called unstable underscore anything is probably not a good idea. So this is not part of React's public API. However, so many libraries and projects are using this that React team declare this as not a public API, but they won't change it without making a breaking change and a new major version. So it's pretty safe to use. I would say avoid it unless it's something that really affects your users and you have no other way to bypass it. So bonus question, look at this code and tell me where is the bug. So I'll give you like a minute to think. So basically we have an input with an onChange event handler. Inside we call setStep, which is some setState function, and we pass in an updater function, and the updater function accesses e.target.value. So I can see your faces or who guessed where is the bug. I'll give you a hint. We already know that the updated function doesn't run immediately. It runs only during the next render cycle. And what you may not know is that React uses a concept called synthetic events, which means that the event object is recycled. They use the same reference for other events, which means that during the next render cycle, you might already get a different reference on this e.target. So you might be referring to the wrong target. So I'm very happy to say that from React version 17, this is no longer an issue. They are not using recycled events anymore. And it's also should be very, very easy to migrate to React 17 because there are absolutely no breaking changes. So you should migrate to React 17. It will also help you with migrations down the road because you will be able to have multiple versions of React on the same page. But if you still can't migrate to React 17, the way to solve this is, one way to solve it is to persist the event, and the other is to extract the value before you call setStep, and then you're using the value which is already extracted from the event. So to summarize this part, React performs event handlers inside the batch. Async code won't run in a batch unless we use unstable batched updates, and events are recycled. Don't use them inside updated functions. Asterisk, with React 17, you don't have to worry about this. Part 4 out of 5. What about reducers? Do we have to do this entire talk from the beginning about reducers? The answer is no, because state is actually a reducer under the hood. Yes, yes, yes. Use state actually calls, it doesn't call use reducer, but under the hood, it uses the exact same mechanism like a reducer. So the setState function, the second argument in the array, is actually a dispatch. And remember, we had the update queue, and we called it an action. We called it an action because states are actually reducers. When you set state and pass in a value, you're actually dispatching this value. The value is the action. And when you call setState and pass in an updater function, then you're actually dispatching the function. So the function is the action. And this is actual source code from React, so just without the types. So this is the reducer that useState uses. It's called basic state reducer. It gets the previous state and the action, and it checks if the action is a function. It runs it with the previous state, and if it's not a function, it's just the value, so it returns the value. So everything we said about state holds for reducers as well, with the update queue, batching, and everything. And now here's another question for you to make sure you are listening and you are awake. If we dispatch an action, will the reducer always run? Is it guaranteed that you put a debugger statement? Will it absolutely necessarily reach this debugger statement? And if you're not sure, let me give you a hint. The reducer, we learned, is performed lazily, meaning only when it is needed. So the answer is quite obvious. No, because it runs lazily, there could be options where this reducer will not run, even though we dispatched an action. For example, if we got some exception between the time we dispatched the action and got to the actual use reducer call in the next render cycle. The second scenario is that the element might be unmounted during the next render cycle, so we won't even get to the use reducer. For example, if our parent component changed some flag and our component is no longer rendered. So to summarize, state equals reducer, and we are in our fifth part, and the last part, is state update asynchronous? So this is more of a philosophical question, and if you try to Google React state asynchronous, you get a lot of articles and blog posts about it, and many of them claim that React state is asynchronous. So is it? Like other stuff in Facebook, it's complicated. So React documentation says state updates may be asynchronous. React may batch multiple set state calls into a single update for performance. Because this props and this state may be updated asynchronously, blah, blah, blah. So they say they may be asynchronous because they are batched. Let's put it to the test. So usually when you think about asynchronous code, you think about stuff that doesn't happen inside the same event loop. It happens in the next event loop cycle. So I added another console log, which is done after promise resolve, which means that it will be performed in the end of this event loop cycle, which means that if this code and the rendering and everything that happens is asynchronous, then we will see the async console log first. So let's see what happens. We click the plus button, and all of the updates and re-rendering happen before the async call. Okay, even though we are running inside the batch. So let's try to hit the plus button again. Maybe it's just a matter of first run. No, we see that every time we hit the plus button, the async code runs less, which means that everything here was synchronous. So what's going on? So the answer is, it's a matter of terminology. So it runs deferred. It doesn't run immediately when you call set state, which feels asynchronous. But in terms of the event loop, it's synchronous. It happens inside the same event loop. That's why I think it's a bit confusing once you go deep under the hood. So, and there's one more thing to remember. We haven't discussed concurrent mode yet, but in concurrent mode, we know that renders can be truly asynchronous. React may say, I know this component is scheduled to re-render, but I have more important things to do. Let's do them, and only then asynchronously render the new component. And we know that state updates happen lazily during render, which means that they can also happen truly asynchronously. And what we just said, that if we're doing batching, then the state updates are deferred but synchronous. But it just feels asynchronous. You call set state and nothing happens. So React recommends us to think of it as asynchronous. And I think it's a good advice, because it's the internal implementation of React, and anyway, we shouldn't rely on the state to be updated immediately after we call set state. To summarize, state updates are queued and computed lazily during render. React bails out of render if the state doesn't change. Either it computes it eagerly or lazily, but it bails out of render. And we know that updates are batched inside event handlers. And we know that state is actually a reducer in disguise. And we know that state updates should be thought of as asynchronous, even though they mostly happen inside the same event loop. Thank you very much. I hope you learned a lot and that you enjoyed. And I'm now open for questions.
Hi, that was a wonderful talk.
Thank
Adam,
you.
thank you very much. And yes, we do have questions for you. So the first one is, do you think anything that is missing from React Hooks API?
React Hooks API, I think it's a pretty solid API. There were a lot of discussions about it when they proposed this API change, and I think Dan Abramov gave really good answers to the considerations behind the decisions they made. I think there are things that I feel like they're missing. I don't know exactly how they should be introduced, but one of them will probably be saving and restoring the state. So I find it quite useful that you can save and restore state, for example, when using Redux, and I think it would be a really good addition to states. I think it can also help server-side rendering and libraries that can support saving and restoring state, debugging, etc. One more thing that I think is missing is more about ESLint rules that they keep improving.
Yeah.
They're really getting better. I think a lot of times you create a custom hook that returns some kind of stable reference, and you have no way of telling the linter that, listen, this is a stable reference. I don't want to include it in the depth array each time. That may be a nice addition. And in my opinion, I think React should support global state using hooks, because everybody's choosing their own state management solution. And then you have to manage local state differently than what you manage global state. And I think it would just benefit everybody if you could just have like this function and you can write use state and you know it's global state, you can use it everywhere. But besides that, hooks are really great and I really love the API.
I love hooks too.
Perfect.
So the next one is, do you recommend using use state or use reducer for complex state?
Do I recommend use state or use reducer? So I like to separate these to two different questions. So the first one is usually, do I want to join the state together to a complex object or keep them apart? And I talked about one of these during my talk. So one motivation to have one object is to make all of the state updates atomic. And then you can rely on the previous state and update the new state based on it. I usually have two rules of thumb. One is that if you have two states, does one make sense without the other? So, for example, a house number in an address doesn't mean anything without the address. So they go together. But also, you should ask yourself, do I usually update them together? Like one update is relied on the other. And in this example, no. Like you can update the house number, you can update the street name, but it really depends on the application. And do I recommend use state or use reducer, which was the original question? I prefer use state anyway, even if it's a complex object, because I prefer to have function calls and not dispatch actions and have switch case statements. I think it's more straightforward, it's less code, and it works better with TypeScript. But I think it's more a matter of style. Like if you're used to writing reducers, if your code base is using Redux, for example, then I think it does make sense also to use reducers in your local state, because then you're managing local state and global state in a similar way, and it's also easier to migrate from local state to global state. Yeah.
Cool. So Let me have a look. Yes, we have question. What do you think about React Suspense? This is asked by Anton.
Um, what do I think about React Suspense? I think it's a very important addition because we were doing this with external libraries before. I haven't used it too much yet, I have to admit. We did use a lot the previous libraries that existed. So I think the API is pretty good. I'm talking about Suspense for code. Suspense for data, I'm really looking forward to having a solid API and try it out and see what it does. I'm not sure it will fall into everybody's workflow because it kind of puts the data fetching strategy inside the React code. And for a lot of projects that I'm working on, usually that happens outside. And you manage this outside. We also have React Query now, which is very good. So yeah, and a lot of times loading state is actually kept in some global state management. So I'm not sure if that would be something I would use a lot, but it looks good. I really like, even if you're not using the React Suspense for data loading, I really like the idea of supporting these fetching strategies and making the UX better. Like you don't load things as they come. You actually orchestrate how new content is added to the page. So I really like the direction of keeping the users in the center.
True, very true. The next one is by Sylvan, and he is asking, what is the difference when your event handler is wrapped in a use callback hook?
So I'm assuming Sylvan meant how does it affect maybe the batching or set state?
Yeah.
So it doesn't, because it just means that the event handler, if, for example, use callback returns the same callback reference as before, it just means that React calls this function again instead of creating a new function and calling it, but it still runs it inside the batch. So it doesn't make any difference. Obviously, it has other effects on the system. So you get the same reference if you send it as a dependency to something else, then it won't trigger this something else to rerun or re-render.
Okay. Cool. So let me have a look. No more questions, but I have a question. So I just want to ask, like, for the junior dev who've started with classes, and they would want to switch to Hook's way of writing the stuff. How would you recommend them? Like, how would they start? For example, what is your thought process?
I think first of all, see the talks where hooks were introduced, because they talk about the motivation and what were the problems before, why did they use this API, and then there's a talk about how to actually use this and pitfalls. So it's a really good talk. It was Sophie Alpert, then Dan Abramov, then Ryan Florence. And then I think the documentation of hooks is really great. I think also for experienced developers, there are a lot of good things inside the React documentation of hooks. They have the FAQ and the reference. It's not very long, and it covers a lot of advanced stuff and a lot of pitfalls. I think it's really good. And also read my blog. I write a lot about hooks and best practices.
Sure. So we have one more question. So do you like Recoil since it comes directly from Facebook and it removes the distinction between local and global state?
First of all, I haven't used it. I looked at the API. It looks cool. So I'm not sure why it removes the distinction between local and global state. Maybe I don't know the API enough. But if they support this option, then it's cool. It looks nice. I really got used to the API of hooks. So, like in my imagination, like the global state should be like the local state. And it's also important to remember that Recoil didn't come from the React team. It comes from some team in Facebook. So it's not like an official part of React. I didn't see any references from the React team that it's going to be a part of React. I think I don't know enough about it to like really give an opinion. I think you should try it and look at it and check it out. But if they do support having local state the same as global state, I think it's great, because that's one of the problems now with state management. By the way, if you use, for example, Mobix, you can use local store, and then also you get like local state and global state the same way, and you get the reactivity to work the same way. And also Mobix is just fantastic, so I also recommend checking that out.
Also, would you mind sharing your blog URL?
Yeah,
So
here
that would be great if we
yeah,
could
sure.
read it from React.js Day. And
Yeah, I'm pasting it now in the. Where should
thank
I
you.
put it, in Hopin or here?
Yeah, I think you can put it in the Hopin as well. And
Okay.
here, yeah. Sure. I think we have no more questions, but anybody from audience who has questions, please feel free to reach out to Adam between the breaks, because he's reachable, and so you can ask him more questions if you have any. And thank you, Adam. It was a really wonderful talk, a lot of insights about
Thank you very
hooks.
much.
Thank you so much.
It was a pleasure. See
Thank
you.
you. See
Bye bye.
you. Bye.